I wanted to go over number 5 from the homework because this is a pretty tricky concept from 6.6. So suppose the probability that an email is a spam email is 35%. And there's a software system to identify the spam emails, and the software successfully identifies an email as spam 95% of the time and successfully identifies a non-spam email 92% of the time. So most of the time we've been doing like positive and negative tests and things like that, vaccines, stuff like that. But this one's just email, but the process is the same. So let's have a tree diagram, not a contingency table. Tree diagrams are much more effective. So first, basically, email is either spam or not spam. Okay, and 35% of the time it's spam. Then 1 minus 0.35, then 65% of the time it's not spam. So then basically now it gets put into a spam folder, so to speak, or identifies it as spam. So basically it's going to say positive, like yes it is spam, or negative it's not. If it's not spam, it's still going to test it and say positive it's spam, negative it's not. So for percentages, the software successfully identifies an email as spam 95% of the time. So if it identifies it successfully, that means it is spam and it says it is. So spam and positive, so that's 0.95. That means 5% of the time it's spam and it says it's not. Okay, and if it's not spam, it successfully, identifies a non-spam email 92% of the time. So not spam says it's not spam. That's going to be 92% of the time. That means the other 8% of the time it's not spam and it says it is. So we'll do our probabilities. So spam and says it's spam is 0.35 times 0.95. Grab a calculator. 0.35. So this is 0.3325. Spam, but says it's not spam, is 0.35 times 0.05. 0.0175. Not spam says it's spam, 0.65 times 0.08, which is 0.0052. And then not spam correctly says no, it's not spam, is 0.65 times 0.92 equals 0.598. So now find the probability that an email is spam and is identified as spam. So we're looking for spam and is identified as spam. That's going to be spam identified, that's spam in a positive test, so to speak. Oops, I need to cross it off. Ugh. 0.3325, sorry about that. So that's going to be right here because this says it's spam, it is spam and it says it's spam. So it's actually just 0.3325 or 33.25% because we're looking out of all the emails, and that's what those probabilities are. Now we have probability of spam given it's identified as spam. So now our denominator is going to be all the ones identified as spam, which is the 0.3325 and this one right here. So this is spam and identified, this is not spam and identified as spam. So our denominator then is 0.3325 plus 0.0052. And how many of those are spam? That's the 0.3325. So this is equal to 0.3325 divided by 0.3377, which equals 0.9846. So the probability of it being spam, if it's identified as spam, is about 98%. And you notice I'm kind of rounding randomly here. It doesn't say, so you can round to the whole number, you can round to the 100th. Doesn't matter too much. Okay, what's the probability that an email identified as spam email is not actually a spam email? That's very similar to part C. Only this one, we're saying email identified as spam. So that's the same denominator, okay? It's still those same. Basically, it's either spam and is identified as spam, or spam and is not identified as spam. But now our numerator is actually the 0.0052, because it's how many is not actually spam. So 0.0052. So this is 0.0052 divided by 0.3377. Sorry, I'm just putting in my calculator. Finish my 7 either. And this is 0.015, or about 0.02, or about 2%. This makes sense because C and D are basically both parts. You have the part that's spam and identified as spam, and not spam and identified as spam, and those add up to 100%.